Hi everyone, welcome to the Smartopers YouTube channel. We are going to discuss about how to find the inverse of a matrix in a tricky way. So what do you mean by a matrix? What is a matrix? A matrix is a rectangular array of elements which are arranged in rows and columns. Okay, so just look, one example is given. A is given as A11, A12, A21, A22. Here, the elements are given as A11, A12, A21, A22. There are two columns and two rows. So, the order of the matrix can be written as 2 by 2, 2 rows and 2 columns. So, which are the diagonal elements of the matrix A? A11 and A22 are the diagonal elements of the matrix A. Now, we can look on another type of matrix which is of order 3 by 3. So, what is the meaning of order 3 by 3? Order 3 by 3 means it has 3 rows and 3 columns. First number denotes the number of rows. Second number denotes the number of columns. So, that is the order of the matrix. So, A is of the order 2 by 2 and B is of the order 3 by 3. Here, we have to discuss about the inverse, inverse of a matrix. How will you find the inverse of a matrix? We have to by heart a formula. What is that? A inverse equal to 1 by determinant of A into adjoint of A. First, we are going to discuss about how will you find the inverse of a 2 by 2 matrix. Just look on a matrix of order 2 by 2. So, I have to find the inverse. So, how will you find the inverse? We will use the formula. What's the formula? The inverse is A inverse is equal to 1 by determinant of A into adjoint of A. Clear? So, we have to find the adjoint of A. So, the trick deals with the adjoint of A. The matrix is A is equal to A, B, C, D. So, it is very easy to find the adj of A. That is, it is a 2 by 2 order matrix, right? In order to find the adjoint of A, you just interchange the elements A and D, then change the signs of the other elements. That means, you just interchange the diagonal elements. What are the diagonal elements? A and D. Interchange the diagonal elements, then change the sign of the remaining elements. Clear? In this 2 by 2 matrix, AD minus BC. AD minus BC gives what? The determinant. AD minus BC gives the determinant. So, finally, we can write as A inverse can be written as 1 by AD minus BC into D minus B minus C A as adjoint of A. Clear? So, in order to find the adjoint of a 2 by 2 matrix, just interchange the diagonal elements, then change the signs of the remaining elements. AD minus BC denote the determinant of A, and the matrix is what? It is the adjoint of A. Clear? Now, we can move to a question where we can apply this trick. So, look on the question. Find the inverse of the given matrix. So, matrix is given. What is matrix? This matrix is given as 2, minus 1, 1, 3, right? So, it is very easy to find adj. We have to get adjoint of A. So, what is adjoint of A? A is obtained by interchanging the diagonal elements. So, the elements will become 3 and 2 here. Then change the sign. Minus 1 will become plus 1 and 1 become minus 1. So, we got adjoint of A. Now, we have to find what? Determinant of A. How will you find the determinant? Just cross multiply it and subtract as in the usual way. Okay, you will get as determinant of A is equal to 3 into 2 minus 1 into minus 1, right? So, you will get as 3 into 2 is 6 and it is 1 plus 1. So, our answer is 7. So, what is our final answer? We know that A inverse is equal to what? A inverse is what? It is 1 by determinant of A into adj of A, right? So, what is determinant? 7. So, 1 by 7 into 3, 1 minus 1, 2. So, this is our A inverse. So, next we are going to discuss about the inverse of a 3 by 3 matrix. How can you write the inverse of a 3 by 3 matrix? Okay. So, where you can apply the trick. So, look on the matrix. The matrix is given as A, B, C, first row, D, E, F, second row, G, H, I, elements in the third row. Clear? So, we have to find a inverse of this matrix. When you are looking on this matrix, it is little bit difficult because this is of order 3 by 3. But it is very simple. Here, first you have to write the given matrix. Okay, the question, a matrix is given. You have to write that matrix itself. So that is our first step. So our matrix is given. So second step is copy the first two columns to the right. That means our matrix is what? Our matrix is A, B, C, D, E, F, G, H, I. So this is our matrix. It is given in the question. What we have to do is first copy the first two columns of the matrix. That means from the given matrix, you have to copy down the first two columns to the right side. So you can write as A, D, G as the fourth column and B, E, H as the fifth column. So next arrangement is take the first two rows. Take the first two rows of the matrix that we have obtained. Rewrite the first two rows to the bottom of the obtained matrix. A, B, C, A, B can be written as the fourth row. A, B, C, A, B. That is same. Okay, these two rows are same. These two rows are same. So when we are doing the problem, it is very easy to write. Okay, now we are explaining this with variables. So just look on the steps, how we can write. Then we can move to the problem. Clear? Now you have to eliminate the first row and the first column. First you have to eliminate the first column. Then you have to eliminate the first row. Clear? So we have eliminated the first row and the first column. Now we get some elements inside this matrix. So in this step, we have eliminated first row and first column. Then ignore the first row and first column while forming cofactor. So we have to form a cofactor. Look on the next step. So what do you mean by cofactor? Consider this as a determinant. Okay, consider this as a determinant. Then cross multiply it. Then cross multiply it. Then subtract. Cross multiply it and subtract. One model is given here. Okay, so look on a determinant P, Q, R, S. How will you find the cofactor? The PS minus QR. PS minus QR. So just cross multiply it, then subtract. That is the value of the cofactor obtained. When you are considering the cofactor in the row wise, you have to write down the values in the column wise. Okay. First find the cofactor of this two. Then find the cofactor of this. Then find the cofactor of this. Step is find the determinant. So how will you find the determinant? Important to consider the elements. Which are the elements you have to take for multiplication and addition? So consider the row of the given matrix. This is our matrix. A is the matrix. This is our matrix. And this is what? This is our adjoint of A. This is our adjoint of A. So in order to find the determinant, just consider the row of the matrix A and consider the column of the adjoint of A. Okay. Suppose it is A, B, C, and it is P, Q, R. So we get the determinant of A as what? AP plus BQ plus CR. So this gives the value of determinant. Clear? Let's move on to the next step. So after getting the determinant, you directly put the values in the equation. Which equation? A inverse is equal to 1 by determinant of A into adjoint of A. So in this way, you will get what? A inverse. So we will look on a question. From this, you can easily find the inverse of A. Just look on here. So first, what is the first step? First step is write the matrix. So what is our matrix? Our matrix is A. So write down 1, 2, 5, 2, 3, 1, minus 1, 1, 1. So this is our exact matrix given, right? So here, the next step is what? You have to write down the first two columns of the given matrix, right? First two columns. So repeat the first two columns. 1, 2, minus 1, 2, 3, 1. Okay. Now you have to do what? You have to consider the first two rows. You have to consider the first two rows. So in the first two rows, you will get what? You have to write the entire row downwards. Okay. You have to write the entire row downwards. So your first row is what? 1, 2, 5, 1, 2. Next, second row is 2, 3, 1, 2, 3. Correct? Now, the next step is what? Just eliminate the first row and first column of the matrix obtained. So eliminate this first row, eliminate this first column. So you will get some elements in a matrix form. Consider the cofactors, then find the values corresponding to the determinant. Okay, that means the cofactors, the values of the corresponding cofactors. Now consider this cofactor and multiply 3 into 1, right? 3 into 1 and 1 into 1. You have to subtract it. So what will you get? So we are going to find what? Adjoint, right? What is adjoint of A? So we are considering in this row wise, write the values in the column wise. So 3 minus 1. 3 minus 1 is 2. 1 minus 1, 1 into minus 1 and 1 into 2. So minus 1, minus 2. Minus 1, minus 2 is minus 3. Now 2 minus of minus 3, right? 2 into minus 1 into 3. That is minus 3. That is 2 minus of minus 3 is 2 plus 3. That is 5, right? Next. So this is our first column of adjoint of A. Now consider the next cofactor, that is 1 into 5 and 2 into 1. So 5 minus 2. 5 minus 2 is 3. Now 1 into 1, 1. Now 2 into minus 5 into minus 1, minus 5. So 1 minus 5 is 1 plus 5, that is 6. 1 plus 5, 6. Minus 1 into 2, minus 2. Then 1 into 1, 1. So minus 2 minus 1 is minus 3. Consider this cofactors. 2 into 1 and 3 into 5, right? So 2 minus 15. What is 2 minus 15? That is minus 13. 2 minus 15 is minus 13. Now 5 into 2 minus 1 into 1. That is 5 2s are 10. 10 minus 1, that is 9. Now 1 into 3 minus 2 into 2. That is 1 into 3 is 3. 2 into 2 is 4. So 3 minus 4 is minus 1. So this is what? This is a matrix obtained and it is called the adjoint of A. Now we have to find what? It is determinant. So what is determinant? There is a trick for finding the determinant. So first look on the first row of the given matrix and look on the first column of the given matrix. So determinant is obtained by determinant of A is equal to what? Multiply this corresponding elements. That is 1 into 2 plus 2 into minus 3 plus 5 into 5. So what is the answer? That is 2 plus 2 into minus 3 is minus 6 plus 25, right? So 2 plus minus 6 is 2 minus 6. That is minus 4. This is minus 4. Minus 4 plus 25 is what? 21. So our answer is what? Determinant of A is 21. What is A inverse? A inverse is equal to 1 by determinant of A into adjoint of A, right? So 1 by 21. And what is adjoint? It is given as 2, 3, minus 13, minus 3, 6, 9, 5, minus 3, minus 1. So this is the value of A inverse. Clear? The answer is what? A inverse equal to 1 by 21 into 2, 3, minus 13, minus 3, 6, 9, 5, minus 3, minus 1. Okay. So in this way, you can find the inverse of the matrices. So I hope it is very helpful for the competitive exams. Try it and practice it. All the best. Thank you.